Good evening, one and all. Today we'll be continuing with our discussion on the programming constructs as well as the printf statement. So before that, I just want to clarify one small error that was there in the previous program that is related to the switch case. So actually we were trying uh, when x is 12, y is 8, we were trying out x bitwise and y. So when I was doing the bitwise operation here, I wrote it as 8, but by mistake I read it as 9. So that's why it was not accepting properly. So according to the 8421 code, this is 12. And when we do the bitwise AND operation between 12 and 8, we'll get 1000. That is 8 itself. Okay, in decimal, 1000 means 8. And since this is 8, the case also, you can have an option of uh, the decimal numbers like 12, 13, 10, 9, whatever, and you can have a case 8 also. And then here you can say, I'll print out case 8. Okay, so when I execute this, since the bitwise operation between x and y is 8, case 8 should get selected. Okay, so when I run this, as you can see, case 8 has got selected. Okay, this 6 number something, that is this one. Okay, so case 8. So what we can say that even the bitwise operations are allowed over here. Okay, as the expression. Similarly, even your post increment, pre increment, post decrement, pre decrement are allowed. So as per the rule, post increment means you will use the current value in the switch over here. You'll use the current value of x over here. Means at this line number, x is equal to 12. And then in the cases, you must have x equal to 13. So let us check how it works. Let me add a case 13 over here and a case 12 over here. So I'll print case 12 and here I'll print case 13 and let us take case 11 also. So it's taking case 12 at the output. Means this was what? It was the post value. So it is taking the current value of x, means over here, as I said, over here at the switch case, what value will come instead of x plus plus, which value will come? Here the value 12 will come instead of x plus plus. And that means the case as well should be 12, right? Because here we cannot write x as the case. We can write only the actual integer value. That is why 12. That means in post or pre operation, we must give the actual expression. If we do plus, so we saw that if we do x plus plus, we have to, the case 12 is selected, means the actual current value of x. If we do plus plus x, let us try. Now it is selecting case 13. Okay, so pre-increment means the 12, first it has to be updated to 13, means inside the switch 13 will be there. That is why case 13 is getting selected. So whatever is the rule, that is if it is plus plus x, first update the value. So the value becomes 13 and case 13 will get selected. But if it is post operation means use the current value and then that value is current value is 12 and so case 12 got selected. So we can also have the increment decrement operation We can have the plus minus over here, and accordingly it will select. We can have the bitwise operation, but we cannot have the logical operation like double ampersand. We cannot use the logical operators. Yeah, we can use only bitwise. And can we use uh, equality checking? No, because it is again a boolean. It means it is a comparison which will return either true or false. Okay, and boolean is not allowed. That is why when we use double ampersand, the result will be either true or false, which is boolean. If we use logical or operation, then also it is what? It is the boolean value it will return. So boolean value cannot come here. Okay, only a number. The number may be coming from bitwise operation, or it may be addition, subtraction, or multiplication. For example, x into 2 also we can try out. So 12 2s are 24. So let's say case 24 is over here. So it will print out this one, case 13. Okay. So you can have these operations, except that you should not get a boolean value here. Is it clear?
Yes, sir.
Okay. So now let us see the for loop. So we have seen while loop. We have to see now for loop. So while loop and for loop is similar, but there is a particular place where you'll be using them. So the syntax of for loop is you'll have one statement, semicolon, second statement, semicolon, third statement. Now each of these statements has certain significance. So statement one is called as initialization. Okay, so instead of statement one, I can write initialization, semicolon. The second statement is a condition. Condition like a greater than b, a equal to b, or a less than b, or a not equal to 0, such conditions. And the next is step count, or you can say step size, or you can say increment decrement, means by how much you have to increase. Suppose initially I is equal to 0, next I should become 1, next I should become 2, next I should become 3, means what is the difference between the consecutive values of I. For example, you can have a for loop like this. For I equal to 0, initialization, right? This is initialization step. Then condition can be I less than 12, suppose, and step count can be I plus plus, or you can write I is equal to I plus 1. So usually we write I plus plus, I minus minus. So here how we know what is the step count is, you must see here I plus plus. I plus plus is nothing but I will become equal to I plus 1. So initially if I is equal to 0, then I will become 0 plus 1, that is it will become 1. Then I will become 1 plus 1, that is 2. Then I will become 3, 4, 5, 6, and so on. So difference between consecutive values means what? You have to take the two numbers which are one after the other, like 1 and 2. So 2 minus 1 is 1. 3 minus 2 is 1. 6 minus 5 is 1. Similarly, 7, 8, 9, 10, and so on you can have. So 10 minus 9 is 1. 9 minus 8 is 1. So this difference is constant throughout. So that is their step size. Means each time I will increase by 1. So these were the three things: initialization, condition, step count. Now how it will execute is, initially it will check I is equal to 0 or not. If I is equal to 0, it will start at that position. Okay, then it will check whether I, that is 0 less than 12. Okay, so first it is going to check the value of I, it is equal to 0. Then it will compare I less than 12. I less than 12 means nothing but 0 less than 12, and 0 less than 12 is true condition. So if it is true, condition is satisfied, and if the condition is satisfied, we can go ahead. Only if the condition is satisfied, we'll go ahead. And ahead means we'll come inside the body of the loop. You can have different statements over here. We'll execute all the statements whichever are between these curly brackets. Okay, and all the statements will get executed. Currently, I value is what? I value is 0 only. Okay. Now, once the last statement is executed, the control, or you can say the steps of execution, will go and check for I plus plus. So it will do I plus plus. So I plus plus will be done means I will become equal to I plus 1. And I plus 1 means what is the current value of I? Can you tell me? Yes.
One.
Yeah. Actually, it is 0. And then you do plus 1, and then it becomes 1. Okay. So now the I value has got incremented by 1. So now I is equal to 1. So what we did first, we wrote I is equal to 0. Then we checked whether 0 less than 12. If it is true, we executed all the statements. Okay. Execute statements. After the last statement, which is within the curly bracket, what we'll check for I plus plus. Okay, so I plus plus means what? I is equal to I plus 1. So I is initially 0, 0 plus 1 is 1. When I is equal to 1, you will uh, again check for the condition. Okay, initially 0, 0 less than this, then you increment it by 1. Then you'll again check for the condition. Okay, because here I was 0. After changing the value of I, you check the condition. Similarly here, the value of I has become 1. Its value has changed, so check the condition first. So you'll do I less than 12. Now here I less than 12 means 1 less than 12 you're checking. And then the value of 1 less than 12 is true. And true means you will enter the body of the loop for I is equal to 1. And then you'll execute all the statements. After the last statement, you will do I plus plus. So now I plus plus means I is equal to I plus 1, and that means I is equal to current value of I is 1. 1 plus 1, which is equal to 2. Okay, so now I is equal to 2. Value of I has changed. So you will first of all check whether the value of I, that is 2, is less than 12 or not. It means 2 less than 12 is true. Then again you'll execute all the statements. After the last statement, again you'll increment the value of I and check it. Okay, so this only you have to do. Only the first time you have to set the value to 0, and then you have to check it less than 12, then execute. Next time increase the value, check whether it is less than 12, execute. Again increase the value, check if it is less than 12, execute. Again increase the value, check if it is less than 12, execute. Now this will continue, and suppose finally I becomes equal to 11. Now I is equal to 11. This 11, you will check it again because value of I has changed. So check it whether it is less than 12. Yes, condition is true. If the condition is true, you will execute the statements. After the last statement, you will do I plus plus, means you are doing I equal, means I will become equal to 12. Okay, after I plus plus, now I will become equal to 12. Once I becomes 12, you will again check whether it is less than 12. Okay, means value of I has changed. So you will check now I less than 12, and here the value of I is 12. 12 less than 12 is what? False. Since this is false, you will not enter the loop. Okay, as soon as the condition becomes false, you will stop. Means the loop is terminated. It's complete, it's over. Okay, did you understand how it works?
Yes, sir.
Okay, so let us see one program over here, and you try to tell me what should be the output. So here again I'm writing I equal to 0. I'm checking I less than 5, and I'm writing I plus plus. So can you guess and tell me what will be the output for this small piece of code?
5 times I
The
will be
letter
printed.
I. 0, 1,
Okay,
2,
so
3.
okay, so I okay, so I think Prahlad is telling me 0, 1, 2, 3, 4. Any other answer? Someone told me that five
I will
times
be
I.
printed 5 times.
I will be
Okay,
print.
what are this? Okay, so some are saying the number will be printed, some are saying I will be printed. So actually, I've written I within double quotes,
I
right?
sorry. I didn't notice that.
Yeah, yeah. So I did that purposely. Anyways, see what happens is sometimes even by mistake double quotes you may write. Okay, so that you must avoid. But this time I wrote it purposely. So I will be printed how many ever times the condition is satisfied. For example, first I is equal to 0. Then what you will do, you will check 0 less than 5, condition satisfied. So you will enter inside the loop. Okay, I'm entering the loop and I will print I over here. Okay, because it is in double quote, means it is considered as a string. Then I printed I. Now I will do I plus plus. Okay, last statement means there's only one statement here. So after doing this, I will do I plus plus. After doing I plus plus, um, I will become what 1. So you will check again condition because value of I has changed, and then you will enter. Once you enter the loop, 1 less than 5 is true, so you have entered the loop. And then again you'll do the statements which are inside the loop. Then you'll again increase the value of I, so I will become 2. 2 less than 5, you will enter the loop. You'll print I. Then similarly for 3, you'll do it. You'll print I. Then I will become equal to 4. You will print I. And then when I is equal to 5, okay, that time 5 less than 5 condition is false, so you will not enter, okay, because condition is false, so you'll come out. So the failing condition, that time I is equal to 5. So sometimes they ask you that what is the final value of I after executing the loop. Okay, this can be a MCQ question. What is the value of I after executing the loop? After executing the loop, I will not be 4. Okay, some will say 4 less than 5 is the last value of I, but after executing the loop, value of I is 5. Why after executing? Because only if the value of I is 5, the loop will end. Okay, so you cannot say that after executing the loop, value of I is 4. No, value of I will be the failing condition of I, that is 5. Is it clear?
Yes.
Okay, so this was some small program, this one only actually. So you can have another example where the step size is I is equal to I plus 2. So let us try this. So here what they're doing is, instead of plus plus, they are doing I is equal to I plus 2. Okay, this is valid. So how this will work is, initially I is equal to 0. So you will check I less than 10, condition is satisfied because 0 less than 10. You will enter the loop, you will print the value of I. So value of I is 0. You may start the value of I from 1 also. Let us take that condition. Okay, you can start the value of I from anything. And here they have written int I equal to 1. Means what? They are initializing over here only. So actually this is declaration int I and I equal to 1 is initialization. They are doing it together. If you don't want to do this, you can also do it like this. Somewhere outside you'll write int I and then you'll initialize it only here. Okay, so this is the declaration part and this is the initialization part. You can put it here. Okay, within the main put it. What is the difference that we'll see later. Okay, within the main you write the declaration. Above the for loop you can write the declaration. So initially 1 will get printed. Now I plus plus is not happening. I is equal to I plus 2. So I is equal to I plus 2. That means I is equal to current value of I is 1 plus 2 and 1 plus 2 is 3. Okay, then you'll check 3 less than 10. If it is satisfied, you'll enter and you'll print the value of I. Current value of I is what? Can you tell me what value will get printed? Hello?
3.
Yeah, 3 will get printed, correct. Okay, so 3 got printed. That was the last statement. So now I have to again increase my value of I. I is equal to I plus 2. Okay, now the current value of I is what? 3, which you have printed. That 3 you have to take plus 2 is equal to 3 plus 2 is 5. So 5 less than 10, that condition you will check. Again, it is satisfied, so you will enter and you'll print the value of I. Value of I is 5. So now again, you'll increase the value of I. What will be the value of I now? I'm doing I is equal to I plus 2. What should be the value? Can you tell me?
7.
Yes, 7. Okay, so each time you have to increase by 2. So 7 less than 10, you will check. It is satisfied, so you'll enter and print the value of I as 7. Then again, I is equal to I plus 2. That means I is 7. 7 plus 2 is 9. And 9 less than 10 satisfied. Enter the loop. Print the current value of I, that is 9. Now again, you'll do I is equal to I plus 2. But this time, current value of I is 9. So 9 plus 2. 9 plus 2 is what? 11. 11 less than 10. Condition fails. So do not enter. Okay. So I will stop. So this is my failing condition now. It is not necessary that here the condition is I can go maximum up to equal to 10, right? I can be less than equal to 10. Okay. So here the case was failing condition is 11. Okay. So here when I come outside, so at the exit, means after the exit from the loop, the value of I is equal to 11 because at that I have failed. So that is my final value of I. Now if I do less than 10, okay. Now in this program less than 10, how it will work is 9 less than 10 acceptable. Okay. And then next is 11 less than 10. So here also failing condition will be same because we are doing plus 2 each time. Okay. So is this program clear to you? How we increase by 2 each time?
Yes.
Okay, let us run this and see. Okay, I need to comment this. And just write the output over here. So we should get 13579. Yeah, we are getting 13579. Okay, similarly, you can have the conditions like I not equal to 10. Okay, but see here, if that is the condition that I not equal to 10, so I'll change it over here. We'll instead of doing less than, we'll check the condition I not equal to 10. So what do you think? Is there a stopping condition over here? Can you see
No.
somewhere?
No.
Yeah. So that is because each time I is not equal to 10 is getting satisfied. See, first of all, I was 1 not equal to 10, condition satisfied. Then it became 3 not equal to 10, true. 5 not equal to 10, true. 7 true, 9 true. And then we did not come across 10. If it was, if somewhere if we got 10 not equal to 10, then that condition would be false and we would have stopped. But since the size is increasing by 2 each time, we have not come across that. So the option is you do I is equal to I plus 1 or you do I plus plus. If we do that, definitely size will increase by 1. So here we will get 10 not equal to 10. Okay. Here all will get conditions like 1 not equal to 10, 2 not equal to 10, 3, 4, 5, 6, 7, 8, 9. Then 10 not equal to 10. This is false condition because 10 is equal to 10. And so this condition is false. And then we would have stopped. So let us try that. We are increasing by 1. So we should get the output like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let us see. Yeah, we are getting it. Okay, at the 10, at the value of I equal to 10, we will stop. Okay, now if I do the previous thing, if I'm increasing by 2 each time, that means I will get odd numbers, right? As I showed you, 1, 3, 5, 7, all these are odd numbers. So if you're starting with 1 and increasing by 2, you will get the odd values of I. And since 10 is an even number, you'll never get 10. And that is why it will go inside an infinite loop, means there is no end to the loop. Infinitely, it will keep on printing all the odd numbers. And we do not have any end to numbers, right? We cannot say that 1 trillion is the last number or anything. There can be no end. The end is infinity. So let us run and see how the output will come. So starting with 1, it should print. See now here what is happening, it is not giving any output because this is in browser, right? So there are certain restrictions maybe and all. So the same program, let us execute in our IntelliJ IDE. Okay. There you may get to see all the values of I. Okay, same program I have written here for infinite loop. Let us see. See, you can see how the values are increasing infinitely. It's not stopping at all. And this is not a good thing to do. So you must end the program. You can click on the stop to end it. Okay. Soon as I clicked on the stop button, which the ID provided to me, I can stop. In command line, you can use Control C, okay, to stop the program. That we'll see later how to program in command line. But I hope infinite loop concept is clear. Now, even in while loop, we can have infinite loop. For example, we can write while true, and we'll keep on writing something inside. It will print infinitely because true is always true, right? You cannot change that. So this is the case for while loop. Now you might have observed that where we can use while loop and where we can use for loop. So compared to the syntaxes, see, for loop syntax is something like this. All the things are at one place. The initialization is here, the condition checking is here, and the increase decrease is over here. For while loop, how the same steps we have. We can write int I equal to 0 or 1 over here. So this is my initialization. Then condition checking will be inside my while loop. For example, let us take j this time, not necessary I always. So let us check the condition j less than 10, suppose. So here is my condition checking. And inside I will write whatever statements I have. And within the while loop, I must do my I plus plus or I minus minus. This time it is j, okay? Whatever condition, maybe j plus plus or j equal to j plus 1. You can also have conditions like j equal to j mod 2. Okay, this is also possible. So this is my condition checking. Sorry, step size. Okay, so if you can see, for loop, what do we have? Initialization, then we have condition, and then we have step size. But in the while loop, inside the bracket, we only provide the condition. Initialization will come before the while loop, okay? And step size will come inside the while loop. Is it? Have you understood the comparison between both the syntax?
Yes.
Okay.
Hello,
Now,
Bhaiya.
yes.
Just now you said that instead of j plus plus, we can have j equals to j mod 2.
Huh.
So how is that going to update the value?
So J will suppose, okay, so mod 2, let us take mod 10 for example. So currently J, suppose let us take 100. Okay. Then we'll see other values of J. So here, initially J is equal to 100. Then I will check the condition 100 less than, suppose say 200 over here, so that our condition becomes true. So I will check 100 less than 200 is true. So I'll get inside my loop. Then I'll execute all the statements. And then J is equal to, current value of J is 10, mod 10. So the remainder is 0, right? Remainder is 0, right? We find the remainder. So 100 is
Yes.
completely, yeah, completely divisible by 10. So the output of the right hand side, this is the right hand side, is 0. So J is 0 now. So J value is changed. So I'll again check my condition. That is, I will check J less than 200. So this means 0 less than 200, which is again true. Since it is true, I'll again execute all the statements, and then I'll come to J is equal to, current value of J is what? 0. And 0 mod 10. That means 0 divided by 10 ka remainder we have to find out. 0 divided by 10. Anything divided by 10 is, 0 divided by anything. 0 divided by anything is 0 always. So again 0 less than 200 I will check, condition is true. Okay, now again I will execute all my statements because condition is true, and then finally I'll come to J is equal to J mod 10. J is again 0 only, mod 10. Here again the value of the remainder is 0. So as you can see, this went into an infinite loop. Okay, because 0 divided by anything, remainder is 0 only because it's completely divisible. So this was again a case of infinite loop. Now suppose you can have a condition like J greater than 200. Okay, or let us take a number which does not give remainder as 0. For example, let us take 3, and let us change J value to 10. Okay, let us try this. So J is initially equal to 10 and J greater than 3 is my condition, suppose. So this also I'll rewrite. Okay, so J equal to 10. Now J greater than 3, so J is nothing but 10 greater than 3 is true. If it is true, I'll enter. I will execute all the statements. Then I will do J is equal to J, that is 10, mod 10. Now 10 mod 10, again remainder is 0. Okay, remainder is 0. So if the remainder is 0, value of J has changed. So I will again check whether J is greater than 3 or not. That means I'm going to check 0 greater than 3. But this is false condition. So this way it has terminated. So not necessary in one case only it will terminate. According to the values and the conditions, there may be many cases, but it will terminate if you write the logic properly. If you don't write, it may not terminate. It may go infinitely. So this is false, so I'll stop. So the loop executed only once. So this is a case where I want to print the statement only once, or maybe only twice, or something like that. Okay, you can also have a couple of conditions inside a while loop. For example, J greater than 3 and J um, less than J greater than 3 and J not equal to 0 maybe. Okay, so even if 0 comes here, I will execute. Okay, so some conditions can be in the form of logical also. Similarly, you can have J, suppose you want a particular range. For example, you want the J value to go from 10 up to 30. So you can say j greater than equal to 10 and that means logical and j less than 30 or less than equal to 30. So it will only accept 10, 11, 12, 13, 14, 15 up to 27, 28, 29, 30. So a particular range of values of j can be printed if you want, or only between 10 to 30 you want to perform certain operation. Maybe you want to find the sum of numbers from 10 to 30. Okay, some things you can do like this, and you already know such programs, right? So these were some conditions, and remember that this condition that you get here should evaluate to a Boolean value. That means when you solve the expression, which is your condition here, when you solve the condition, it should be either true or false. Suppose we give 1 over here. Now you may say 1 stands for true. Okay, if you know C, C++, we can, this is allowed. Okay, while 1 means 1 stands for true in C, C++. But here say it's giving a warning that the required type is Boolean and you are providing integer. So in Java, you cannot give such conditions like while 1. Also, you cannot give while 0. 0, you may say it stands for false, but you cannot give it inside the while or for. If you write while 100 or while 10, that is also not allowed. You may say, now remember one thing, examples like 10, minus 20, 100, all these are non-zero values. And if you have a particular non-zero value, it is considered as a true value. Okay, non-zero values are considered as true. You may have 0, which is considered as false. But this does not work with Java, as I'm saying. Okay, so 10 is not possible. Though 10 is a non-zero value, which should be considered as true in C, C++, it is not considered as true inside the while condition. Okay, so only that you can also write true over here inside the while, or you can write a condition, which is a comparison operation or a equal to operation, or you can have not equal to operation. Okay, such things that result into a Boolean value is only allowed inside the for or while. Any doubts still here?
No.
Okay. So these were some points which you need to remember. And there is lots of other things also, like if you put a semicolon over here after the for, what happens, and so on. So these type of questions are asked in your placements usually, because everyone knows how for loop works, how while loop works. But have you ever tried putting semicolon here and so on? So there are so many things that you need to consider. Suppose you miss this condition over here, what happens? If you write int I over here and you don't write int I over here, what is the change? Okay, there are different things that you need to take care, and that discussing now is not needed actually. So when we need it actually, that time a separate video I'll try to do it, not now, but okay. So there's one more loop. Do you know any other loop which we can have? Have you heard of any other type of loop?
Do while.
Do while.
Yes, correct. So we have that in C, C++, Java, but we don't have it in Python. So do while and while are similar, but actually the output that you'll get will be a little different because of the way it executes. Now the syntax is do. Okay, the keyword it is do. Open your curly bracket. You'll write certain statements over here, and then close your curly bracket. Then you'll write while. Here you'll write the condition like a greater than b, and then semicolon. Okay, this is the syntax of do while loop. Now how this executes and how is it different from while loop? For example, do while I less than 5. Okay, and suppose initially I have written, we know that the initialization for while or do while is outside the loop. Okay, it can for do it can be inside the loop also. Okay, so for example, let us study the loop side by side. I'm writing while also over here. And here no need of semicolon. Okay, and here you need a semicolon. Here you need a semicolon. And there's one more thing, that is condition increasing, that is I plus plus, I minus minus. Okay. And here you can initialize, suppose, starting from 1, suppose, for both the loops. Now how the output will differ? Now in this case, the output, let us see, for while loop, let us see first. For while loop, the condition also has to be written here, I less than 5. Okay. So first you'll print the, suppose I want to print the value of I. Okay, that is my statement. My statement is nothing but print I. Okay, I'm writing in short form. Actually, what you have to write, system.out.println. I'm writing here print I. Okay, so you can understand what it does. So it will print the value of I as 1. Okay, so you know that first I is equal to 1, it will check the condition 1 less than 5 true. So I'll print the value of I as 1. Then I will become what, 2. Then 2 less than 5 is correct. So I'll print the value of I as 2, then 3, then 4. 4 less than 5 true. So I printed the value of I as 4. Then I did I plus plus. So I became 5. 5 less than 5 false. So I did not enter, I stopped. So my failing value of I is 5. So let me also write, this is not the output, this is just note. Note that I fails at I equal to 5. Now what is the do while, how it works? Same thing, but checking the condition will be done later on. So first what you'll do, I is equal to 1. There's no condition checking over here. Nothing is you have to check over here. What you will do, you'll directly print the value of I. So you'll print the value of I as 1. Then you will do I plus plus. So initially you printed I equal to 1. Then what you did, you printed you increased the value of I. So I became plus 1, that is I became 2. Then you will check the current value of I. I has become 2 now. I was 1, you printed the value of I as 1, you increase the value of I to 2. So this is the value of I that you have to compare. What you'll compare? You'll compare 2 less than 5. So as you can see, in the do while, our first comparison was 2 less than 5. But in the while, our first comparison was 1 less than 5. Do you agree with me?
Yes.
Yes, sir.
Yes. Okay, so this was the change. Okay, this is just one change. So initially we checked for 2 less than 5. Okay, in the do while, 2 less than 5. So it is true. Okay, so I'll again, I have checked the condition is true. So I'll again go inside my loop. Okay, condition is true means what? I'll go inside my loop. What is there inside my loop? Printing the value of I. Now the value of I that will get printed is 2. Okay, so 2 I'll print. And then I is equal to I plus 1 means I is equal to 2 plus 1 means I is equal to 3. Now you'll check 3 less than 5. 3 less than 5 is what? True. It is true. So you'll again enter the loop. You'll enter the loop means you'll print the value of I. I value is what now? 3. Now I is equal to 3 means now you'll increase the value of I by 1. So I will become equal to 4. And you will check 4 less than 5. Condition is true. Since the condition is true, you'll go inside the loop. You'll print the value of I as 4. Then you'll again increase the value of I. It will become 5. Then you will check 5 less than 5. So condition is failing over here. 5 less than 5 is false. So you'll not go inside. So here again note that I fails at I is equal to 5. So here, as you can see, the first comparison value is changing. Okay, that is one change. And the failing value is same. Okay, so that is one similarity for this case. Okay, it is not for all cases. So let me write first comparison may change, may be different. Okay, that is one thing that you should know. First comparison may be different. Okay, usually it happens most of the cases. Now if we do like this, if I write the initialization over here, okay, inside my do I'm writing the initialization. So now how the output will change. So yes, any doubt? Your voice is breaking.
No, no.
Okay, so int I is equal to 1 is inside the do. Okay, it is not outside the do. So I is equal to 1 initially. Then you're going to print the value of I as 1. So output you got 1. Then you did I plus plus. So I became equal to 2. Then you will check 2 less than 5. Condition is true. Since the condition is true, what you'll do, you'll enter inside the loop again from the beginning. But what you have the first statement? You have the first statement as I is equal to 1. So what happened now? You reinitialized, or you can say you updated the value of I as 1. So I became equal to 1. Now instead of, see, whenever you do int I, it is like creating the variable again and again, right? So what you should do, you can write int I outside and then do I equal to 1 inside. Okay, this is usually preferred, like, okay, because always doing int I equal to 1, int I equal to 1, instead of that, int I outside. So you have declared it once and you will re-update, or you'll keep on updating it again and again. So I is equal to 1, you printed I equal to 1, then I became equal to 2. Then you check this condition, 2 less than 5 is true. So you'll enter the loop. I again became equal to 1. Since I is equal to 1, you will print I equal to 1. So again 1 will get printed. Then I will become 2. And 2 less than 5 will check. Condition is satisfied. Again you'll enter. So again I is equal to 1. Again you'll print 1. So do you think this will go up to infinity? Yes or no?
Yes.
Yeah.
Yes, sir.
So this is again a case of infinite loop. So as you can see, there are so many cases. If you do not handle them properly, it can go infinitely. Now, what is the application? You have heard me saying that it is not good to go inside infinite loop and so on. That is true because the memory of your computer is limited. So if you do not stop somewhere, it may consume a lot of space and your system might crash. Then what is the application? Like, why is this concept? It has some applications also. For example, your traffic signal. If your traffic signal is off or it is not given the power supply, it will not work. So as long as the power supply is given, means as long as the power supply equal to true, it should execute, right? If it does not execute, then you will not be able to handle the traffic on the roads. So this is one example. Another example, you might have seen the hoardings along the roads. There, at the night time, since people may not be able to see clearly, they put the maybe some colorful lights on those hoardings or something like that, like changing lights. Sometimes the red color hoarding might be seen, sometimes blue color, sometimes green color. Okay, depending upon which colors they use. So continuously it follows a pattern: red, green, blue, red, green, blue, red, green, blue. So this pattern should go on infinitely. So this is another application of infinite loop. So these are some real-time applications. So it is also having some application, but for our programs, usually we do not use it, right? So I hope you have understood this. Now another case, suppose I have I is equal to 1. Now another case of infinite, okay, leave that. I is equal to 1 and I write over here I less than, or I write I greater than 5. Okay, now see what will happen over here. Initially int I, then I equal to 1, you'll print the value of I. Value of I is 1, so output you got 1. Then I plus plus, so I became 2. Now you'll check 2 greater than 5. False. False. False means you will not re-enter, you will stop. So you got the output as 1. Okay, for the do while. Now the same logic, if I write inside my while loop, what will be the change? We will see that. Here also int I equal to 1. Print the value of I plus plus, and this. Okay, let us see the output now. So initially int I. Now here you will get an error because you do not have the value of I. Or you, since it will, if we do not assign the value of I over here, suppose 12 or something, it will take the garbage value or it will give you an error. Okay, so let us test that also. If you do not, means why I'm saying error or garbage, because int I and then you're comparing I less than 5, but what you'll compare, what is the value of I, you do not know, right? You have not mentioned what is the value of I. But in do while loop, what was happening, since the condition checking was at the end, here you were able to initialize and no error was happening, means it was not any exception or anything. Here value of I was found. You have mentioned I is equal to 1, and then you are checking the condition. But here that is not the case, right? Condition checking, and then you are mentioning what is the value of I. So these are two different cases which happens. So let us check this case now. This case in the IDE. So initially int I, what is the value of I? We don't know, but we are still comparing. So what will happen? Let us see. So as you can see, it is highlighting I. What it is saying, variable I might not have been initialized. So it is an error. Okay. Let us execute still and see. So you're getting an error. In C, C++ usually takes the garbage value, means if you do not store any value, whatever value was previously stored, means the variable I will be assigned any memory location inside your memory, and whatever value is there at that memory, that would be considered. It is called as garbage value, but that is not the case with Java. So what is the case over here is, this was one change, that you'll get an error if you apply the same while loop for this logic, but in do while loop it works fine. Now suppose I do I is equal to 1 over here. Here also I do I is equal to 1. I remove this here. So in do while you'll get the same thing. You'll print the value of I as 1. I becomes equal to 2. Condition is false. So output is 1. Now here int I equal to 1. I less than 5. Okay, so I don't need this. What is the output? Now same thing. I is equal to 1. 1 less than 5 is what? It is true. Uh, Greater than, sorry. Okay, the condition is I greater than 5. So I is equal to 1. 1 greater than 5 is false. Since it is false, I will not execute the loop even for one time. Even once I will not enter inside. So what is the output? Nothing, right? You will not get any output. So this is the difference, that int I equal to 1, you executed the loop and then checked the condition. And then the condition was false, so you did not go inside the loop again. But once you went inside the loop, means at least once you will definitely go inside the loop, okay? Means irrespective of the condition, whether the condition is true or false, always once the loop has to get executed in case of do while. Do you agree with me?
Yes.
Yes, sir.
Right, because you do not care if this condition was true, then you'll execute the loop second time. If this condition is true, you'll execute the loop third time, fourth time, and so on, as long as the condition is true. But if the condition is false for the first time only, still you have executed the loop once, so only you got the value of I as 1, right? So irrespective of the condition, since you are checking it after the execution of the loop, at least once the value or the execution will happen of the loop. But in case of while, since the condition is being checked before executing the loop, the condition is false for the first time itself, so you did not enter the loop even for one time. Once also you didn't enter the loop. That is why output was nothing. Is the difference clear?
Yes.
Yes.
Everyone?
Yes, sir.
Yes.
Okay. So this was some differences. So another thing, here you need to know the value of I in case of while, and then you will check the value of I greater than 5 or not. Suppose you do not know the value of I initially. You are only writing int I in case of do while. Then you'll execute some statements, and then depending on the statements, your value of I changes to 12, suppose. Okay, what I'm saying, initially you do not know the value of I, but we know that do while will definitely execute for one time. So some statements are there in the do while. For example, you can have a statement like I equal to 3 into 4, right? Something you will have. So for example, I equal to 3 into 4. So after some steps inside the do while, okay, inside the do while, after performing some execution, you will get the value of I as 12. Okay. Here also you may have some statements, and after some time you're getting the value of I. And then definitely you've got the value of I, so you can compare it over here. But that is not the case with while. You have to have the value of I, and then only you can think of executing the loop. But within the loop also you can get the value of I for the first time. Is this clear what I'm saying?
Yes.
Okay. So I think we had started at 5:15 and now it's 6:15. So 1 hour is over. So if you have any doubts, you can ask me, else put your attendance in the chat box. And once you put your attendance, if you do not have doubts, you can leave. Thank you. And please practice all this. Okay, write your own programs. Like you might have seen in your first year programs, like printing the even numbers. Okay, so you may print the even numbers up to 10, maybe up to 100 or so on. You also might know the logic of prime numbers. Okay, you might also execute Armstrong number if you know the program. Then finding if the number is positive or negative, finding the number if it is even or odd, finding if the number is negative or positive, or if it is zero, or what is the greatest number among three numbers ABC. Okay, so many different programs you already have executed in Python, I suppose. So just try it out. Okay, before I explain all those, just try it out so that you feel confident when I explain those programs. Okay, that is one suggestion I want to give you. And any doubts you can ask me now. No doubts? Shall I end the meeting?
Yes.
Okay, thank you.
Thank you.
Yeah,
Thank you.
Thank you.
welcome. Welcome.